Welcome back, everyone. Today, we are going to explore an exciting yet crucial stage of the machine learning lifecycle: model deployment and prediction service. This is where all the hard work of developing your machine learning model transforms into something that can actually be used in the real world. It's not just about making predictions, it's about making those predictions accessible, reliable, and ready for action. Let's break it down step by step. So, what does model deployment actually mean? In simple terms, it's about making your model operational and accessible. You've developed your model, you've trained it on data, and now it needs to be put into production where it can make predictions. This can happen in a few different places: on a device or in the cloud. The location depends on your specific needs, such as how quickly you need the predictions or the resources you have available. And here is something important: deployment doesn't just happen once. Responsibility for deployment can vary. Sometimes the team that developed the model will also handle deployment. Other times it might be a different team entirely, which can cause some communication issues and slow updates. Now let's talk about how predictions are made. There are two main types of prediction: batch and online. First, batch prediction. This is like having a big batch of data and making predictions on all of it at once. It's often done offline and predictions are stored for later use. Imagine, for example, generating weekly reports or analyzing customer data. Batch prediction is perfect for these kinds of tasks where real time data isn't necessary. On the other hand, online prediction happens in real time. This is necessary for applications where immediate results are crucial. For instance, think of real time delivery time estimates you need to know right away. Online predictions use both batch data and streaming data, giving you the most up to date information. It's a more complex setup, but absolutely necessary for scenarios where speed is the priority. Sometimes we even use hybrid solutions where common queries are pre-computed in a batch, but less common ones are handled in real time. This is a great way to strike a balance between speed and efficiency. So, how do we make these predictions available to the user? This is where model serving comes in. You can think of model serving like a delivery service. It's the infrastructure that makes your model's predictions accessible. The model is exposed as an endpoint, which means whenever you need a prediction, you just trigger that endpoint. Whether it's an online prediction or fetching a pre-computed result from a batch, the model is always ready to serve. But here's something that can help you out: model compression. Deploying models, especially large ones, can be resource expensive. So, how do we make them lighter and faster? There are several techniques for this. Low rank optimization. This simplifies the model by using smaller matrices, reducing the overall size without sacrificing too much performance. Knowledge distillation. This technique involves transferring knowledge from a large, complex model, the teacher, to a smaller, faster model, the student, which can achieve similar performance with fewer parameters. Pruning. This removes less important parts of the model, making it smaller and quicker. Quantization. This reduces the precision of the model's numbers, using 8-bit integers instead of 32-bit floats, for example, saving memory and speeding up computation. When it comes to where your model runs, you've got a choice between cloud deployment or edge devices. The cloud is great because it offers scalable resources, allowing you to run models with heavy computation needs. If you have a lot of data or need to process a huge volume of predictions, the cloud is your go-to solution. But sometimes you don't want to rely on the cloud. You want your model to run locally on devices. This is where edge devices come in. Edge deployment helps you reduce latency and improve privacy. It's like having your model right on the device, so there's no need to send data back and forth to the cloud. The catch: models on the edge need to be smaller and more efficient because these devices have limited processing power. Now, once you've deployed your model, you still want it to run as fast as possible. That's where inference optimization comes into play. The goal is to make your model predictions faster and more efficient. There are plenty of new hardware options specifically designed to run machine learning models quicker. making the whole process much smoother. We also need to talk about failures in machine learning systems because unfortunately things can go wrong. In a traditional software system, you might encounter bugs, but in ML, there are a few unique failure modes. Production data drift. This happens when the data used in production starts to differ from the data the model was trained on. It can make your model produce unreliable results. Edge cases. These are those rare, weird situations that models don't always handle well. Think of it like those outlier situations that can really throw off a prediction. Degenerate feedback loops. This is when the model's predictions start influencing the data it receives, which in turn affects the predictions again, creating a cycle that can amplify biases or reduce performance. So, to wrap things up, model deployment is a critical phase in the ML lifecycle. Batch versus online prediction has its place depending on the need for real time results. Model compression helps make models smaller and faster, and you'll need to choose wisely between cloud versus edge deployment depending on your use case. Finally, you need to be aware of potential failures like data drift and feedback loops that can impact your model's real world performance. If you found this video useful, make sure to hit like and subscribe for more insights on machine learning and model deployment. And remember, deploying a model is just the beginning. Keeping it running smoothly and efficiently is what ensures your ML systems truly succeed. Catch you in the next one.